Okay, guys, hello. We're gonna be doing lectures, chapter 8 video. After that, you're gonna have a test on chapter 8, and after that, we're gonna find finals a week before. So let's start with 8.1 sets. Set is a well-defined collection of objects. It can be anything from numbers, animals, name of people, whatever you want. Set braces are used to enclose the numbers belonging to the set. Elements, members, numbers or objects that make the set. To show that a number or of an object belongs to a set, we use the symbol and write 4 belongs to the set 3, 4, 5. This is read as 4 is an element as a set of 3, 4, 5. We can also use this symbol to show that the element is not part of a set. For instance, this reads as 9 is not the element of the set 3, 4, 5. Now, empty set. The empty set is denoted as this symbol, and this is a set without any elements at all. Every set has an empty set. Example, set of female presidents in the United States is an empty set since we do not have any female presidents yet. Note, be careful that the 0 is not confused with this symbol or this. They are not the same. 0 represents a number, a placeholder. Empty sets means nothing in the set. And 0 is a number, an element, a member of the set. Equal. Two sets are to be called equal if and only if they contain exactly the same number of elements or the same elements themselves. Example, 1, 2, 3 is equal to 1, 3, 2, which is equal to 2, 1, 3, so on and so forth. They're all equal because to each other since they have the same elements, despite the fact that they're arranged in different forms. Set builder notation. Sometimes we describe a set by a common property rather than by its elements itself. This reads, the set of elements X such that X has property P and represents the set of all elements X having some property P. So let's do the first example. So list the elements belonging to each of the given sets. So A, X such that X is a natural number less than 5. Well, what is a natural number? A natural number is 1, 2, 3, 4, 5, so on and so forth to infinity. So if we have this, then our set, which has to be between the brackets, sorry with that horrible thing, we know that it's 1, 2, 3, 4. And this would be our answer since the set states less than 5. For B, X such that X is a state that borders Florida. Well, that would be Alabama and Georgia. And as stated before, the sets can be anything we want. Universal set. In a discussion, a universal set is a set that contains all of the objects being discussed. A set A is a subset of a set B, written like this, provided that every element of A is also an element of B. A set A is said to be a proper subset of set B, written this way, if every element in A is an element of B, but B contains at least one element that is not a member of A. When A contains an element that is not in B, then A is not a subset of B, and we write like so. So for each case, we have to decide, on the next example, we have to discuss or decide if M is a subset of n, M is a proper subset of n, or none of the above. Okay, so A states, M is the set of all stocks that at least doubled in value over the course of a year. N is the set of all stocks that at least tripled the value over the course of a year. Well, since some stocks doubled in value, sorry, let me rewrite that. Sorry. Since some stocks that doubled in value did not tripled in value, we can say there exists elements in M that do not, and this is the magic word, do not exist in N. Therefore, M is a proper subset of N. Now B. M is the set of all stocks that increased in value over the course of the year. N is the set of all stocks that increased in value by a penny or more as listed as a stock exchange over the course of the year. Okay, so let's think. We, as the nation, our lowest currency would be a penny, correct? So to be able to increase, that increase must be at least by a penny. Therefore, any stock that increase has to increase by at least a penny. Therefore, M is a subset of N since there are no stocks in N that are not also in M. M is the set of all stocks priced $50 or higher in January 3, 2017. N is the set of stocks priced $50 or higher on January 2, 2018. Some stocks that are in M that are not in N, because some stocks can drop prices below $50. So for this one, we do not know, so there we have it. Note, every set A is a subset of itself because the statement every element on A is also an element in A is always true. It is also true that the empty set is a subset of every set, as stated before. So, decided E is a proper subset of F. So A, we have E is equal to 2, 4, 6, 8, and F is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since all elements in E are in F, but F has elements that are not in E, then we can say that E is a proper subset of F. So B is the set of registered voters in Texas. F is the set of adults aged 18 years or older. Okay? So, again, this is also a proper subset. Why is that? Well, to be able to vote in Texas, you must be at least 18 years of age. But not every 18-year-old is registered to vote. Then finally C. E is a set of diet soda drinks. F is a set of diet soda drinks sweetened with NutraSweet. Some diet soda drinks are sweetened by something else, thus it's not a proper subset. So let's list all possible subset of each of the given sets. Okay? So for A, we have the empty set. We have 7. We have 8. And we have 7, 8. Yes? Now for B, this can be a little bit more complicated. Because it's a little bit longer. So we can use what is known as trees. So we always start at the empty set. And 1, 0. Or let's put this as T for truth, F for false. Okay? So let's put this a little bit better, a little bit lower. That would be better. And that would be for letter A. And then truth, false. That would be for letter B. Truth, false. And then we have truth, false for letter C. Truth, false. And truth, false. And truth, false. So if we want to write all the subsets, we're just going to follow this little pattern. So for B, we're going to start with the empty set, which is right there. Okay? Then we're going to start with truth for A, so A is there. Truth for B, so B is there. And truth for C, so C is there. So we're done with that. Then we're going to start again. Truth for A. Truth for B, but not for C. False for C. And then we're going to do truth for A. False for B. And truth for C. And finally, we're going to do truth for A. So we continue. Now we have false for A. So it's truth for B and truth for C. And then we have truth for B but false for C. And then we have false for A, false for B, but truth for C. And false for everything, so that would be nothing, empty set. Okay? So that came up with 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 possible answers. Correct? Which this takes us to the next step. Since there are only 2 possible outputs, meaning either the element's there or it's not there, or true or false, we can see that the set with 2 elements has 4 answers. In this case, we have 2 to the 3 answers, so we have 8 possible subsets. 1, 2, that's what we have there. Okay, so find the number of subset for each of the given sets. Okay, for A, we go 2, and we have 1, 2, 3, 4, so that's to the 4th power, so that's going to give me 16. For B, we have 2 months of the year. Well, we have 12 months, so that's going to be 2 to the 12, which that should be 4096. And C, remember it's the empty set, so that's a 0, and there's nothing there. So any number to the 0 power, it's 1. Venn diagrams are used to illustrate relationships among sets, operation on sets. Complement. Given a set A and a universal set U, the set of all elements of U that do not belong to A, this is read as a complement of A. Meaning, if we have A, the complement of A, it's going to be every element that's not there. Okay? So A is equal to 1, 3, 5, and 7. Now we're looking for the complement of A, so those are the elements that are not in A. Well, A, 1, yes, it's there. 2 is not there, so there we go. 3 is there. 4 is not there. 5 is there, but 6 is not. So that 2, 4, and 6 is the complement of A. B. Again, set B has 3, 4, and 6. So B complement would be 1, 2, 5, and 7. Because set B does not contain those elements or members. Now, C. Empty set is empty, right? So the complement of empty set would be the universe. So, set. And the complement of the universal set would be the empty set. Intersections. Given 2 sets A and B, the set of all elements belonging to both A and B is written as this. Upside down U. Understood? So, for A, we have 9, 15, 25, 36, intersection 15, 20, 25, 30, 35. Okay? So, what's the intersection? What numbers that are both on the left or on the right? Okay, the 9's is there, but it's not on the other one, so let's scratch it out. 15, perfect, both. So 15 is in both. What about 25? Yes, 25 is also in both. 36, Nope. 20 is not on this on the left. 30 is not on the left. And 35 is not on the left. So, therefore, this is our intersection. Now, B. We have X such that X is a teenager. Intersection X such that X is a senior citizen. Well, no teen is a senior. So, therefore, this is an empty set. I repeat, since no teen is considered a senior citizen. Disjoint events, two events that have no elements in common, except, of course, the empty set. Now, union, the set of elements belonging to set A or set B, or to both. Okay? So, for A, we have 1, 2, 5, 9, 14, and it wants us to find the union 1, 3, 4, 8. Well, remember, the definition of union is the set of all elements belonging to set A or to set B or to both sets. So pretty much we have to join everything together without repeating. So that's 1, 2, 5, 9, 14, 3, 4, and 8. B. Again, that would be every simple little dog there. So it would be terriers, spaniels, chows, Dalmatians, Spaniels already mentioned, collies, and bulldogs. This I recommend you to learn because this is all the operations of the set. Okay? Let me erase this. I already done it. Sorry. Delete. There we go. So let's start. So A. The following table gives the 52-week high and low prices, the last price, and the change in price from the day before for 6 stocks on a recent day. So stock high, low, last, the change. Let the universal set U consist of the 6 stocks listed in the table. Let A contain all stocks with a high price greater than $50. B, so that's the one we want. B states all stocks with a last price between 25 and 80. Okay, so for B, last stocks between 25 and 80. So that's going to be this one and this one. So First Solar and Verizon, right, are the ones that apply to this. But we need B complement. So we want the ones that are not between 25 and 80, and that's going to be Ford, IBM, sorry with that horrible B, Netflix, and Procter and Gamble. So that makes up A. Now B wants A intersection C. So let's erase our little table again. So B, A contained all stocks with high price greater than 50. So greater than 50, that's going to be A. High, this one, this one, this one, this was pretty much everything with except for Ford. And C is all stocks with a negative value for the change. So that's going to be this one, this one, this one, and this one. So now we want the intersection or and. Both conditions must apply. So that's going to give me first solar. Ford does not apply. IBM does. Netflix does not apply. That one doesn't apply. But Verizon does. Now we're going to do AU. So this is A. We need to do B again. B was all stocks with price between 25 and 80. So that would be this one. 25 and 80. And that one. So this is a union, so it's pretty much everything that applies to either one or the other. So that's going to be for solar. Ford is not mentioned. IBM because it applies to the high. Netflix because it applies to the high. Procter and Gamble. And finally Verizon. And this concludes lecture 8.1. I'll be putting up 8.2 in a couple of minutes.